When I first heard about this interstellar object, it was very exciting just from a scientific point of view that finally there...
After all these years of NASA's existence, they don't seem to get everything right with rocket inventory and technology. They've been battling with lots of rocket technical challenges, yet there hasn't been any headway, nor was there any country to run to for solutions in the turbulent days. Until SpaceX came on board. As NASA's messiah, the company would have continued to struggle, moving sluggishly without success. That's why as soon as NASA perceived SpaceX and Elon Musk knew their onion in the space program, especially in launching the Falcon 9 rocket and installing the Starlink network in space without hitting the rock, then boom, NASA embraced it as an open door, or call it an opportunity for them to land their astronauts on the moon. They have believed in SpaceX up to the extreme of giving them a whopping $2.9 billion contract. Now, haven't you thought about it for once yourself? Why didn't NASA have over the contract to Virgin Galactic or Boeing, which has also been in space game for long? Yes, you know the answer. Well, it's nothing but that NASA believes that SpaceX will take them to the promised land, the moon. And right now, NASA is at it again. They've been working on the SLS rocket for a long while, and it has been a headache for them. Fortunately, Elon Musk is around this time, and NASA had to consult him, save them from rocket headache, which was launching their astronauts to the moon earlier. But this time around, it's about the recent leakage of the SLS rocket. What solution did Elon Musk provide to this leakage, and how will it give hope to NASA's rocketry science starting today and in the future? Stick around to the end of this video as we explore all of these interesting facts. NASA cancelled the launch of Artemis 1 on the 3rd of September because the mission teams could not fix a fuel leak in a line that brought liquid hydrogen to the tank in the core stage of the Space Launch System SLS rocket. The mission was supposed to take off from the Kennedy Space Center during a 2-hour launch window, but it was cancelled 2 hours and 28 minutes before the launch. The recent delay happened because the leak was found at the 8-inch quick disconnect that brought propellant into the tank could not be fixed. Engineers tried several times to fix the problem, but they were already behind schedule, so Artemis 1 mission director Charlie Blackwell Thompson decided to cancel the launch after being told it was a no-go and not ready for flight. During the countdown, the mission teams filled the SLS rocket's core stage's liquid oxygen tank to its total capacity. However, the hydrogen tank was only about 10% full because of the leak. The 212-foot tall core stage of the SLS rocket has 2 tanks, one for liquid oxygen, cooled to negative 181 degrees Celsius, and a larger one for liquid hydrogen, cooled to negative 252 degrees Celsius below it. If Artemis 1 had taken off, it would have been in the air for 37 days, 23 hours and 53 minutes, ending on the 11th of October. But the leak won't have made it successful. Elon Musk, who knew about the SLS failure, had to come into the movie and give NASA's engineers the best advice of the year to get the SLS up and running without failing. But giving it a quick thought, why didn't NASA ask Elon's engineers to test the SLS for problems before putting it on the launch stand? Well, if you know the correct answer, please leave a comment below. Elon Musk has said something about the delay of the Artemis 1 launch, which was caused by a leak in the SLS rocket while NASA was putting fuel in it. NASA said that the leak was a quick disconnect, an 8-inch supply line that was used to add and remove fuel from the core stage of SLS. Since the Mega Moon rocket was moved to the launch pad at the Kennedy Space Center, this was the 4th time liquid hydrogen had leaked. And from NASA's tweet, reads and quotes, the Artemis 1 mission to the moon has been postponed. Teams attempted to fix an issue related to a leak in the hardware transferring fuel into the rocket, but were unsuccessful. Here is what the master of space rockets of our time, Elon Musk, thinks about NASA's SLS drama. So let's talk about Elon's insight about the SLS failure. Even though this fuel is considered suitable for launching rockets, it is tough to control because hydrogen is the lightest element in the universe. Even a tiny hole lets the hydrogen gas escape, so Elon Musk, the CEO of SpaceX, switched one of his rocket engines from hydrogen to methane. Raptor design started out using H2 or hydrogen, but switched to H4 methane. Latter is the best combo of high efficiency and ease of operation, Musk tweeted. He also said the velocity difference between methane and hydrogen as propellants is small, and methane needs a smaller tank with less insulation. SpaceX has made 5 engines: the Merlin, Kestrel, Draco, Super Draco, and Raptor. These engines are used in its Falcon 9 rockets, Dragon spacecraft, and Starship vehicle. SpaceX hasn't made a mistake with all these different rockets, so Elon is on the right track when he tells NASA what to do to fix the SLS leakage. But why does NASA use liquid hydrogen while SpaceX relies on liquid oxygen and methane? NASA still uses liquid hydrogen even though it is hard to handle and keep it safe during tanking operations. This is because the US Congress has made it a requirement. According to a report by Eric Berger in Ars Technica, Congress told NASA in 2010 to use engines, propulsion systems, and other hardware from the Space Shuttle program for the SLS. Currently, NASA only lets a maximum of 4% hydrogen leak out while propellants are loaded into the rocket. However, the recent leak was more than twice as much as this, even though all of these rules say so. But it is a suitable fuel because it helps rockets propel faster during launch. Combustion, a situation that has to do with burning fluid and converting it to gas, releases energy, which makes things propel. Start with something to burn or fuel, something to make it glow, or an oxidizer, and you have power. For SLS to fly, combustion needs to happen in two main places: the main engines, which are Aerojet Rocketdyne RS-25S, and the twin solid rocket boosters, which are made by Orbital ATK and provide more than 75% of the thrust at liftoff. Both propulsions are powered by combustion, but the fuels and oxidizers differ. Hydrogen is the lightest element and is usually found as a gas. It is used as a fuel for the main engines. Light hydrogen has low density. This means that a small amount of hydrogen gas takes up a lot of space. To have enough power, a large combustion reaction in a rocket that will fight against the Earth's gravity, it would need a huge tank to hold it. This is the opposite of what is needed for an aerodynamically designed launch vehicle. Turn the hydrogen gas into a liquid denser than gas to solve this problem. This means bringing the temperature of the hydrogen down to about negative 423 degrees Fahrenheit, that's about negative 253 degrees Celsius, and that's going to be very cold. Since liquid oxygen is denser than liquid hydrogen, it needs to be compressed into a liquid to fit in a smaller, lighter tank. Oxygen is cooled to negative 297 degrees Fahrenheit, that's negative 183 degrees Celsius, to turn it into a liquid. Even though LOX is better than LH2, both propellant ingredients must be handled carefully at low temperatures. Also, the cryogenic LH2 and LOX evaporate quickly at standard pressure and temperature, so the rocket can't be loaded with fuel until a few hours before launch. Once the LH2 and LOX are in the tanks and the countdown to launch is almost at zero, they are pumped into the combustion chamber of each engine. When the fuel is ignited, the hydrogen explodes with the oxygen to form water, which then burns in the combusting chamber. This happened to NASA's SLS rocket, but it didn't burn up. Instead, there was a gas fume right at the top. The reaction between hydrogen and oxygen makes a lot of heat, which makes a green flame, aiding the combustive fluid vapor expand and shoot out of the engine nozzles at 10,000 miles per hour. The fast-moving steam gives the rocket the thrust it needs to leave Earth. But one thing that makes all of these stages work is impulse. This is the measure of the efficiency of rocket fuel and describes the amount of thrust per amount of fuel burned. The more push off the pad you get per pound of fuel, the higher the specific impulse. But even though LH2 has the highest specific impulse, its low density means that carrying enough LH2 to fuel the reaction needed to leave Earth's surface would require a tank that is too big, heavy, and has too much insulation to protect the cryogenic propellant from being practical. Since the hydrogen tank on the SLS isn't very big, the LH2 gas has to fight its way through a slight opening and emits into the air. What's your POV? Do you suggest that NASA hands over the SLS rockets project to SpaceX? After all, the plans are that NASA SLS and SpaceX Starship make the greatest double launch never seen before. Will they succeed? Just click on the video to know more about this.